Right, so previously we have gone through the intersecting of two pipes of the same size at 45 degrees. And this is great and all, but students have to progress to a level where they can actually identify how to actually get this shape. It's good and all knowing where it comes from, but they have to identify how they get it, where they take the point to find points here, 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 and here, say. How many points to divide it into, all this. So I feel I will make use of the visualizer here, and we'll go through a question similar to this one, but different. So we'll just put this out of the way over here. And now, I have the rough gist of this question sketched out, so I can fly through it quicker. So firstly, what we'll do is we'll get a few of our gel pens as they show up nicely on the visualizer. So firstly, we'll draw our front elevation of this pipe. So we come along and take our biggest set square all together. Take her all the way up there. Perfect. Take it over here. And take it up to here. This turns out to be intersected afterwards, so I won't take my lines through there, I'm just taking them through here originally. And I'll explain to the students why. Now, to speed up the process, I've decided to put my plan into the bottom of the pipe, which has no real effect afterwards, as it'll be brought up here. So, firstly, we'll divide up our, sorry no, this gel pen is gone. So we'll divide up our line, like so, and we'll find our center point and swing our compass along it to draw our plan. Down here, and up there, so. Next, we will mark off where our intersecting object will be cutting, looking in from the front plane on the two, where it'll be cutting the base object. So the two extreme points. So here's one. And we're going to give this a radius, or intersecting pipe a radius of 108. So 108 in diameter. Sorry, now the gel pins are failing me. No. So 108 in diameter. So we have our 108, bring it up to the top of the line, so I'll just scrub this in and use this color set. Now, we'll take it back to where it's cutting our base object. Now, next we'll divide this up into 7 equal parts. So we'll have 1, 2, 3, 4 this way, and 1, 2, 3, 4 this way. So we'll label them in 1, 2, 3, 4, 1, 2, 3, and 4. We will divide this up using our compass. So swing our compass from the center to here. Then we'll put it on our top point, swing it down there, get a cut. Top point, swing it here, get a cut. Once we have these cuts established, we'll get our compass, swing it here, and get our compass, swing it there. We will keep the same radius the whole time when we're swinging it. So from this point and this point we'll swing, get 2 cuts along our semicircle, and we'll do the same on the other side. We'll bring these generators back then. So just using my marker here. We'll bring them back from out here, like so. 1, 2, 3, and so on. When I'm going through this with the students, I'll take all the points. So bring them back. So we'll label them inside here then. We have 4, 3, 2, and 1. And these points came from below, where we got our compass again. This radius was used, as this is the intersecting pipe, which will be up here, so we need to use the same radius. And we used our plan to see around the outside where it actually intersected. So we had 1 point here, 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 and here. Brought them up, labeled our points down here, 1, 2, 3, 4. Have our points up here, 1, 2, 3, 4, 1, 2, 3, 4, and found them. There, 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 and there. So now we'll just draw this in. We'll use a different colour. Like so. This isn't more so about accuracy, it's more so about showing the steps in how to actually find the intersection. So we have our points. Next, we must find the actual cut, the area that is going to be actually cut by the intersecting object. So this is what you'd see, or something similar. Obviously, this one is coming in from below, and when we looked at this one, it was coming down from the top. So if you rotate it upside down, we can see side by side they look very similar. Now, the one difference is this is a different size radius in the intersecting pipe. So up here we have our new radius. So let's swing down and around. And stop here. Swing our circle. Divide it again into our equal pieces. So we have 1 there, 2, 3, 4, 5, 6, and finally 7. Bring them down. So bring them all down. And bring across our points which we found in intersection. We must be careful that we don't bring across points out here, here, anything silly. So we use the last step we had. Bring them across and we find them all around here. Now we'll draw this in again. Like so. So now we'll outline our true shape, or our true surface, sorry. There we go. There we go. Obviously, for the front elevation, this will be going straight up, but as we have our end elevation incorporated into it, I won't draw the line heavy. And the same with our plan below. Now, where it actually gets interesting for the students is calculating how we'll actually put our object, our intersecting object, onto this one. So we'll go in and get a separate sheet. We'll calculate the radius that was used to draw the circle, and from this we can calculate the perimeter of the circle. Once we have the perimeter, we can take a length here. In this case, since we used 102, it ended up being 320 long. So our diameter was 102 and our perimeter ended up being 120. So I divided this into 12 and I used our points around here. So since we had 6 points, divided into 12. So I took our major height, so this is our major height here. So major height, MH, and I put it on to point 1 out at the edge. So major height went on here. And I done this with all the points. So major height was point 1. And it's obviously over on the far side here, point 1 again. It went 1, 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 2, 1. And I found my points the whole way around. So then scribe in my points. Obviously, we can have a discussion with students that we might have mirrored it instead. This might save us time. And I'll just fill in the bottom. Now, what we'll do with the students next is cut this shape out and see, does it actually fit onto our pipe? So we'll get our scissors, we'll come along, like so. You can turn that off. Yes.